So, what if the whole future of computing isn't about packing more tiny transistors onto a chip? What if it's about tapping into the weird and incredibly powerful rules of quantum mechanics? We're going to dive into a company, IonQ, that's betting everything on exactly that. They think they've found the key to a whole new era of technology.
And wow, the prize they're going after is just staggering. We're talking about an economic value, according to analysis from IonQ, that could hit $1 to $2 trillion by 2035. I mean, to give you some perspective, that's bigger than Amazon right now. This isn't just a new gadget we're talking about. This is something that could literally reshape, well, everything.
Okay, so you have this massive trillion-dollar prize just sitting there, but the race to get it includes absolute giants, right? Like Google and IBM. So how does a company like IonQ even stand a chance? Well, their whole argument is actually pretty simple, but it's a big deal. They think they're starting with a better building block, a better atom. Yeah, their entire game plan starts at the most fundamental level you can even imagine.
All right, so this is where IonQ's entire case rests. It's all on this one really bold claim that they've picked a better fundamental building block. They actually believe they found the perfect qubit, that basic unit of quantum information. And they think it's so good, it gives them an advantage that's almost impossible to beat. So, let's see if that's true.
So in the quantum world right now, there are really two big technologies fighting it out. On one side, you have IonQ's approach. They use what are called trapped ion qubits. And what that means is they're using literally individual atoms just floating perfectly in an electromagnetic field. They call them nature's perfect qubits. Why? Because every single atom of, say, ytterbium is completely 100% identical to every other one. That means you don't get these tiny little manufacturing mistakes that can mess up the competition's approach, which relies on man-made superconducting circuits.
So, okay, why does choosing an atom versus a little circuit matter so much? Well, it really all boils down to quality. IonQ says their trapped atoms give them a huge lead in three key areas. First up is fidelity. Think of it like a perfect sound system with zero static. The music is just crystal clear. They're saying their qubits have way less noise. Then there's coherence. That's basically how long the qubit can hold on to its fragile quantum state before it just poofs. And lastly, you've got connectivity, which is all about how well the qubits can talk to each other to get real work done.
And this table, man, it really lays out the difference. That fidelity jump from 99% to 99.99%, I know, it looks tiny. But in the world of quantum computing, that's the difference between a kind of fuzzy, maybe right answer and a perfectly sharp one. But then, look at coherence. We're talking seconds versus milliseconds. That's 1,000 times longer. It's like having 1,000 times more time to work on a really hard puzzle before everything resets. It just opens the door to way more complex stuff. And that all-to-all connectivity, it means every qubit can talk to every other qubit directly. It's a true network, not like the other guys who can only pass messages to their next-door neighbor.
Okay, so the tech is clearly impressive. But let's be real. In the business world, having the coolest tech is only half the story. The billion-dollar question, or trillion-dollar, I guess, is does this actually translate into a real-world business advantage? And from what IonQ is showing, the answer is a big, flashing yes.
And this is where things get really wild. Look at the unit economics here. A big IonQ system is projected to cost less than $30 million. A comparable system from the competition? Over $1 billion. That's more than 30 times the cost. And it gets better. IonQ's machine can fit into standard data center racks. The other guys need a facility the size of a football field. And the power consumption? It's just mind-blowing. The IonQ system basically runs off a regular wall socket, while the competing systems need the kind of power that could run a small city. I mean, the implications for cost and actually being able to scale this stuff up are just enormous.
For a long time, the whole quantum industry was obsessed with one thing, the raw number of qubits. It was this bigger is better race. But IonQ came along and said, hold on a second. That's like judging a car just by the size of its engine, without ever checking its real horsepower or how fast it goes around a track. So they helped create a new way to measure performance, one that focuses on what actually matters. Can it solve hard problems?
And they call it the algorithmic qubit, or just hashtag AQ for short. Think of it this way. AQ is a single number that tells you how powerful a quantum computer actually is when it comes to doing useful work. The raw qubit count might tell you how many musicians are in the orchestra, sure, but the AQ tells you how complex and beautiful a symphony they can all play together. It's a much better measure of real power. And here's the chart they used to back it all up. Back in September 2023, their tempo system hit an AshQ of 64. Now, I know, 64 doesn't sound like a huge number, right? But because of how quantum computers scale, that represents a computational space that they claim is, get this, 36 quadrillion times larger than the competition. That's a number with 15 zeros. On a chart like this, you want to be way up and to the right. That's where you're solving the biggest, hardest problems. And as you can see, IonQ is pretty confident they're playing a completely different game.
But here's the thing. Having a tech lead is great, but it can disappear overnight if you're not careful. So how do you protect it? You build a moat. Just like a medieval castle, right? It's not enough to have the tallest tower. You need thick walls, a drawbridge, and a really deep moat to keep competitors out. And that's exactly what IonQ is trying to build around its core tech.
Their whole strategy really comes down to three main pillars. Pillar 1, keep building the most powerful quantum computers in the world. Easy enough, right? Pillar 2, build a super secure network so these computers can talk to each other. And Pillar 3, develop incredibly sensitive quantum sensors. The end game here is to become the one-stop shop for absolutely everything quantum. They want to build an entire ecosystem that's just too hard, too complex for anyone else to copy.
And they're not trying to do all this from scratch either. In 2023, they went on a pretty serious strategic shopping spree. They snapped up Oxford Ionics to really scale up their manufacturing. They grabbed Vector Atomic to get their hands on premier quantum sensing tech. They also bought companies to build out their quantum networking. You can see this isn't random. It's a very deliberate plan to own every piece of the puzzle and corner the market.
And hey, don't just take their word for it. Look at who's lining up to work with them. They're the only quantum company that's available on all three major cloud platforms, AWS, Microsoft Azure, and Google Cloud. They're working with huge companies like AstraZeneca and Hyundai, and they have major contracts with government agencies like DARPA and the Air Force. This isn't just a fancy slide with a bunch of logos. This is a huge vote of confidence from some of the most demanding customers in the world.
So when you look at all this, the future for IonQ seems incredibly bright. But, any good investor knows that where there's huge potential, there's also huge risk. It's kind of like standing at the edge of a cliff, right? The view is absolutely breathtaking, but you're also very aware of how far down it is. And that's the paradox you get with any company trying to do something this big.
So you've got the bear case and the bull case. The bears, the skeptics, they'll look at the company's valuation and say, whoa, that's way too high. It's priced for perfection. They'll point out that IonQ is still burning through a ton of cash and that their roadmap is, let's be honest, ridiculously ambitious. But then you've got the bulls, and they'll come right back and say, look, this is a once-in-a-generation shot to get in on the ground floor of a company that has a clear technology lead, a history of actually doing what they say they'll do, and a full-stack plan to win the entire market.
So, that's the big question, isn't it? Is IonQ really building the future of computing? Or is this all just a really compelling, beautiful dream? The answer? Well, it's not just about the future of one company. It could actually define the entire next era of technology. The race for quantum advantage has officially begun.